Lesson 7 in higher differentiation is curve sketching. Curve sketching involves something we've done already in lesson 5, which is identifying stationary points. And the other essential thing we have to do to score all the marks on what will be a 9 or 10 mark question possibly is identify where the curve cuts the x-axis and y-axis, as it says on the bottom of page 9. So here's an example from page 10 in your notes. To sketch the curve y equals 8x cubed minus 3x to the 4. Well, the order doesn't really matter, so I'm going to do the new bit first. Where does it cut the x-axis and y-axis? Well, when a line cuts the y-axis, the x-coordinate, 0 along, so the x-coordinate must be 0. So let's just put, considering for x equals 0, what happens? Then y is equal to 8 lots of 0 cubed minus 3 lots of 0 to the power of 4, which is, of course, simply 0. So that tells us one point on our curve must be the point 0, 0. That's where it cuts the y-axis. When it's cutting the x-axis, well, on the x-axis, 0 up, so that means the y-coordinate is 0. So again, I'm going to go with this equation, but instead of putting x 0, I'm going to say that y is 0. That means my 8x cubed minus 3x to the 4 equals 0. And I'm going to write it that way around so I can solve it. So 8x cubed minus 3x to the 4 gives me a y value of 0. So there it's there. Solve in the usual way, that is, always look to factorize first. So I've got a common factor of x cubed. If I take out my x cubed as a common factor, I've got 8 minus 3x equals 0. Two things multiplying to be 0. Either the first thing equals 0, which gives me x is 0, which I expected because I already have identified that the point 0, 0 is on my curve. So that works there. Or my second term equals 0, which means if I take 3x equals 8, that's me taking the 3x to the other side, if you like, adding 3x to both sides technically. Of course, I'm not moving the 3x. And then just writing it this way around. So x is 8 over 3. 2 2/3. So this point is 8 over 3 and a y-coordinate of 0. So I've identified two different places on the curve. If you like, for just a very rough little sketch to see what my progress is so far, I'm saying this point is on the curve. And this point at the point 8 over 3 along is also on the curve. So this is, I don't have to do this, I just like to do this with a little sketch and just to see what my progress is so far. So I've got two of the points. But I've still got to identify, of course, the stationary points. This equation tells me coordinates, tells me points, as we've said before. To get gradients, which is stationary points at gradient 0, I need to differentiate. So, starting from y equals 8x cubed minus 3x to the 4, to get all the points for stationary points. First thing is for saying I'm going to differentiate, sometimes scores a mark. Working out the derivative certainly scores a mark. So 24x squared minus 12x cubed. Now I'm going to say set this equal to 0, a line people often forget to write because that's for stationary points. As we have already said, the gradient must be 0 for a stationary point. And so for setting the derivative equal to 0 and writing this equal 0, that scores a mark. Make sure you do that, please. All right, I'm going to solve this now. So again, I will factorize. 12 is a common factor. So is my x squared, which will give me 2 minus x equal to 0. So 12x squared equals 0 gives me x is 0, dividing both sides by 12. Second stationary point occurs where 2 minus x equals 0. If I solve that, x must be 2. For the first point here, if x is 0, well, we already did this on the, previously. We said when x is 0, y must be 0. You can write the working again, but there's no need. Coordinates of this stationary point as 0, 0 for x equals 0. And over here, I'll say for x equals 2. Y, remember the first equation tells me points. So y is 8 lots of 2 cubed using the first equation, minus 3 lots of 2 to the power of 4. 8 times 8 is 64. Take away 3 lots of 2 to the 4 is 16, so that's 48. And so my y-coordinate here is 16. So I have another stationary point at 2, 16. And then if you remember with stationary points, we investigate the nature, because that will help me draw the curve to see the shape. Is it a minimum or maximum turning point? Is it a point of inflection? So we need a nature table. So for my first one, x coordinate 0, a number to the left of 0, a number to the right of 0, but to the right of 0, but not going as far as my x is 2 point here. Here's going to be my dy by dx. And of course, the slope, or what the line looks like at that point. Dy by dx when x is 0, my gradient is 0. I can double check just to make sure I've not made a mistake. I go up to my derivative formula here. 24 lots of 0 take away 12 zeros. That is indeed 0, so that works. At that point, it's horizontal, which is what I was wanting. What's the gradient doing before 0? Well, there is no other stationary point to the left of 0, or less than 0, so I'm going to just put in something like negative 10 in my thinking. You can use negative 1 if you prefer. I go with the extreme one. 24 lots of negative 10 squared, that's 100. 2,400 here. Take away negative 10 cubed is negative 1,000. Negative 12 times negative plus 12,000. That dominates this. So that gives me a positive dy by dx here. Any number I put in less than 0 will give me a positive gradient. So my line is coming up. So we're going to have a maximum turning point or a point of inflection. A number between 0 and 2. So I'll use 1. That's a nice simple number to put in. Again, in my gradient formula. 24 times 1 squared. Take away 12 times 1 cubed. 24 take away 12 is 12. That's positive. So again here, positive answer. So this, in fact, 0, 0 was a point of inflection. I'm going to do another little nature table here, where I'm considering the number 2, numbers before 2, numbers after 2. I'm just going to actually continue this one along. Should really put a line in here, the line along here. At 2, again I can check up in this equation up here for my derivative. If I substitute in 2, my gradient is 0. So that's a stationary point. Before 2, well, again, this is where sometimes I say people merge this table just into 1. These results here will be identical to these, because if I'm picking my number more than 0 is 1, I may as well say my number less than 2 is also 1. So same results. The line left my stationary point here going up and is continuing up here. What's happening past 2? Again, you can use 3 or 4, or I prefer 10 is a nice big number again. Nice round number. 24 times 100, 2,400. Take away 12,000. 2,000 take away 12. Definitely negative. So when I go past 2, it's a negative gradient. So it's going down. So my point 216 is a maximum turning point. Now the question didn't ask me to, but I may as well put in point of inflection, because sometimes the question will ask me that, and I will get marks for just identifying these and to say 216 is a maximum turning point. Because that could be an extra mark right there just for merely taking the results from this up to here. Well, let's see what we've got now. I said, and this would be our so-called neat sketch. You, of course, will be using a ruler because you'll have both hands free. Now, I do not need to mark the scale on here, especially because I'm looking to go 16 up. But I must on here identify the coordinates of the critical points. That's where the curve cuts the axis and the stationary points. We said this 0, 0 was both a stationary point and indeed a point where it cuts both the x-axis and y-axis. So here's my y-axis and my x-axis. We said the point 216 is a stationary point. So I'm not putting a scale in, but I am going to write that this is the point 216 to identify it. And in fact, when we look at this stationary point and this stationary point, of course, from here to here, any curve or any line must be going up the way. This must be positive gradient here, which is confirmed on my table here. There it was, a positive gradient going up. Here it is again, the same thing, or it might be in one table. But between my stationary point of 0 and my stationary point of 2, it must be going up. The very coordinates told me. So that's a little check that we've done this bit correct. If that was saying, no, this was the negative gradient going down, but we look at the coordinates of the 2 points, then we've either worked out the y coordinate wrong or we've done our nature table wrong. But that would ring the little alarm bells. We said this was a point of inflection. When you draw this in, right, do make sure that at this point, we're not just doing a little gradual slope of like 45 degrees or so, that we do momentarily make it look as if it is going horizontal. And that up here, we said this is a maximum turning point. So don't make it jagged. Let's make it a nice smooth curve, round hills, right? Not jagged mountains. So smooth curve coming around past that stationary point. Again, momentarily gradient to 0. Coming down here, and where it cuts here, remember we said this is the point 8/3, 0, which is 2 2/3. Again, that makes sense. If this is 2, this value down here must be more than 2. So we're saying that's that point here. And it looks like the curve goes on down here. I'll just say that's that point there to make that clear. And this, of course, is 0. Final thing is check what's happening to the equation of the curve when the x-coordinates are getting extreme. When x is getting very large and positive this way, or when x is getting very negative this way. So let's have a look and see what happens. In the original equation, y equals, let's say x is going very positive. All right. So again, you can use 10 or 100 or anything. 8 times 10 cubed, that's 8,000. Take away 3 times 10 to the power of 4, that's take away 30,000. 8,000 take away 30,000. That's definitely a very negative value for y. So when my curve is going this way, with x is getting larger, my curve is getting more and more negative, which is what happened when I drew it in. So that was a good result. we look for the same, we're looking for the same thing when my x is getting very negative. Now, according to what we've sketched in here, if this was a point of inflection here, then my y-coordinate should also be very negative. So let's check again, extreme value here. Y is 8 times negative 10 cubed. That's negative 8,000. Minus 3, negative 10 to the power of 4 is plus 30,000. But then it says take away my plus 30,000. So that's going to be a negative answer overall. Negative 8,000, take away 30,000 in the end is negative 30. So very negative, negative 38,000. So this curve is good. Now for doing this sketch and identifying these key points where it cuts the axes and the stationary points here and here are clear, that and having a smooth curve, horizontal here, not just going up diagonally like this, but turning horizontal and then continuing up and then being like part of a parabola up here, maximum turning point and coming down again, that scores extra marks again. And that is quite simply how we do curve sketching.